Hello everyone, today I will show you how to use DarwinFPV's HiLink HD Video Transmitter, VTX. First, we need to solder the 4-pin cable to the flight controller according to the VTX pinout. Please note that the TX pad on the VTX must be connected to the corresponding RX pad on the flight controller. The RX pad on the VTX must be connected to the corresponding TX pad on the flight controller. When installing the VTX on the drone, ensure that the two antennas are tilted upwards as much as possible, and the ends are widely separated to avoid crossing, reducing signal interference. Next, I'll demonstrate how to connect to the VTX using a mobile phone. First, open your browser and search for PixelPilot. Click the top GitHub link, scroll down to the bottom. And click on the latest software under Releases. Once opened, click on pixelpilot.apk below to download it. After downloading, click the package to install it. After installation, open the app, then power on the VTX and wait for it to boot up. Wait for about 15 seconds, turn on Wi-Fi, find OpenIPC, click Connect, and enter the password 12345678. Once connected, return to PixelPilot, and you will see the video feed successfully displayed. Once in the video feed, you can test for latency and stuttering. Next, let's talk about how to configure the VTX parameters. Okay, after plugging in the drone's battery, we wait for about 15 seconds, then click on Wi-Fi, and find OpenIPC. Click Connect, and enter the password 12345678. After connecting, search for 192.168.0.1 in your browser. And enter the root password 12345. After logging in, this is the main interface. It displays various information about the VTX. Let's click on HiLink FPV. Okay, once we are on this interface, this SSID is the VTX's Wi-Fi name. Next to it is the Wi-Fi password, which you can change according to your personal needs. After making changes, remember to click Apply and Restart next to it. Below that is the VTX bandwidth. A smaller bandwidth offers stronger penetration but slower transmission speeds. A larger bandwidth has weaker penetration but faster transmission speeds. This channel below is the Wi-Fi channel. You need to choose this based on surrounding interference. Generally, the default channel 165 is cleaner than lower channels. Click Apply after selecting. The option on the right forces a network card driver reset. It's mainly for common driver errors with cards like the RTL8812AU. Under normal circumstances, please do not click this. This one resets all VTX settings and restarts. It's mainly used to one-click restore default parameters after making a settings error. The VTX power output below is used to set the VTX's transmission power. Slide left to decrease power, slide right to increase power. Lower power means a smaller signal coverage area, weaker penetration, but the VTX will generate less heat. This is suitable for debugging or close-range flying. Higher power means a larger signal coverage area, stronger penetration, but the VTX will generate more heat. Suitable for long-distance outdoor flying or complex terrains. Adjust according to your flying needs. When increasing power, always pay attention to the VTX temperature and cooling to avoid burning out the VTX due to overheating. The video mode below is the video format. The leading 16:9 refers to the aspect ratio. 1080p is the video resolution. 60 is the frame rate. The trailing 50 Hz AC is anti-flicker, used to prevent strobe effects caused by lighting under a 60 frames per second frame rate. OSD size adjusts the size of the OSD text and icons. A smaller value means a smaller size. A larger value means larger text. Adjust according to your equipment and preferences. Flip image refers to flipping the screen. This is useful when the camera is mounted upside down due to wiring or by accident. The overshoot fix below refers to overexposure and whitening repair. It fixes issues where the camera transitions from very dark areas to very bright areas, causing the image to turn white and lose color due to overshoot. HQ iframes below refers to high-quality iframes. It effectively prevents long-lasting mosaic blurring caused by accumulated errors after violent rolls. It is recommended to keep the default HQ majestic default. Further down is focus mode. HQ center is the high-quality center mode. This feature increases the bitrate in the center of the image while compressing the bitrate around the edges, allowing for a clearer central image within limited bandwidth. It is highly recommended to enable this. Flight controller refers to the VTX serial port selection. Select it based on the corresponding port used to connect your VTX to the flight controller. Max MCS is used to control the upper limit of Wi-Fi modulation and coding. The higher the limit, the higher the bitrate, and the clearer the image quality. However, penetration is weaker, making it more prone to packet loss and artifacts. Conversely, the lower the limit, the lower the bitrate, and the blurrier the image quality. But penetration is stronger, and the video feed is more stable and smooth. Link resilience below refers to link resilience. Sliding left will use a higher MCS, making the image clearer but more susceptible to interference. Sliding right will use a lower MCS, resulting in less detailed image quality but a more stable and smooth video feed. Maximum throughput on the right is the max bitrate throughput limit. The higher the value, the higher the image quality limit. But when facing interference, it's more prone to fluctuations, stuttering, and frame drops, and the temperature will be higher. The lower the value, the lower the image quality limit. But the video feed is more stable, anti-interference capability is stronger, and the temperature is lower. The LQ consideration below is the link quality consideration strategy. It adaptively adjusts the image based on current signal quality. Lowest means taking the worst signal value between uplink and downlink data as a reference. Downlink only means taking only the downlink data as the standard, unaffected by the signal transmitted from the ground station to the air unit. Temp throttle threshold means the overheating throttle threshold. Its function is to actively reduce the VTX power when the temperature reaches the set value and lower the CPU operating frequency to reduce heat generation, preventing the chip from burning out. A threshold that is too low will cause frequent throttling and power reduction during flight. A threshold that is too high may cause the VTX to overheat, causing irreversible damage. CPU overclock is the CPU overclocking option. Keep it disabled under normal circumstances. Only use it when insufficient CPU performance causes encoding frame drops, UI stuttering, or similar situations. Before using, ensure adequate cooling and try increasing it gradually. Next, we click on Majestic at the top, click Settings, and then click Audio to enter the audio settings. If you want to hear audio from the air unit, turn on the microphone and speaker options. Microphone volume is used to adjust the mic volume. Audio sampling rate is the sampling rate, and codec is the encoding format. Keep both of these at default. Next, click Record at the top and turn on the Enable Recording option below to start SD card recording on the air unit. Among the three options below, recording path refers to the storage location of the video files. Keep the default. File limit in minutes refers to the maximum length limit for a single video. Limit of available space usage refers to the SD card's available space limit. Choose according to your personal needs. Next is how to flash and update the VTX firmware. First, we need to use the 8-pin to RJ45 network cable included in the package. Insert the 8-pin plug into the VTX interface, and plug the other end into the computer. Then power on the drone. Next, we search for and open the control panel on the computer. Click Network and Internet. Click Network and Sharing Center. Click Change Adapter Settings on the left. See if a new network has appeared. If not, or if it shows a red X, check if the connection is incorrect. Then, double-click to open Properties, find Internet Protocol version 4, check it, and double-click to open it. Select Use the following IP address, enter 192.168.1.3 in the IP address field, and enter 255.255.255.0 in the subnet mask field below. Click OK to save when done. Immediately after, open the folder containing the firmware, type CMD in the address bar at the top, and press Enter to open the command line. Once opened, enter the command shown above and press Enter. Note that you need to change the red text according to the different firmware names. After pressing Enter, it will ask for confirmation. Type Yes and press Enter. The typed content will not be displayed. Then enter the password. The passwords are all 12345. The typing process will also not be displayed. Press enter to confirm when finished. Next, transfer the second part of the firmware. Likewise, copy the command line above and press enter. Same as the previous section, it needs to be modified according to the firmware name. Then enter the password 12345 and press enter to confirm. Immediately after, you can make an SSH connection. Copy the code above and enter the password, which is also 12345. After connecting successfully, we need to confirm whether the firmware transfer is complete. Enter the code above and press enter. After confirming there are no errors, we will enter the flashing code. Note that the red part also needs to be changed according to the VTX firmware. After entering it, wait for the flashing to finish. That concludes the basic usage tutorial for DarwinFPV's HiLink HD VTX. Wishing everyone happy flying and may you never crash.